splicing. So suppose if you want to join a metallic wire, what we do? We go for soldering, or we put a knot. So in case of optical fibers, there is a special process called splicing. Splicing is nothing but joining of optical fibers. So joining of optical fibers can be done by two processes: mechanical splicing and fusion splicing. So first let us talk about mechanical splicing. So this mechanical splicing is again classified into two different types: electrometric spiles and four-rod spiles. So before connecting the optical fiber, we should confirm that whether the connection is a temporary one, or whether the joining is a temporary one or a permanent one. So if it is a permanent connection, permanent joining, we call it as splicing. If it is a temporary one, we call it as connectors. So this mechanical splicing is classified into two different types: electrometric splicing and four-rod spiles. So first let us see about electrometric spiles. So this electrometric spiles consist of a rubber-like material. Inside this rubber-like material there is a small hole, and this electromer is covered with a glass sleeve. It's covered with a glass sleeve. Now the optical fiber which has to be connected is inserted in this small hole. So this is the hole in which the optical fiber is inserted, which has to be joined. So now by adjusting the glass sleeve, this optical fiber can be made into, that is, two optical fibers can be made into contact by applying an index matching gel. So by applying an index matching gel, it gives a good grip to the optical fiber. Now the two optical fibers are joined. So this is how an electrometric splicing is done in optical fibers. Next type of splicing is four-rod splicing. So this four-rod splicing consists of four rods. At the end of the rod there is a small curve. At the end of the rod there is a small curve which holds the optical fiber. So if a fiber has to be connected, suppose this is an optical fiber which has to be connected, the four glass rods are connected in such a manner. So the optical fibers F1 and the optical fiber F2 which has to be connected is also inserted in this four rod, and a small pressure is applied. So due to the application of a pressure, these two optical fibers, that is fiber F1 and fiber F2, are joined. After applying a pressure, an index matching gel is applied over the joint for better grip. So this is how and four probe splicing is used to connect the optical fibers. So these type of connections are permanent one. So next is the fusion method. So in case of a fusion method, we are having a sophisticated instrument which produces an electrical arc. So now the optical fibers which has to be connected, suppose these two are the optical fibers which has to be connected, fiber F1 and fiber F2. Now so this instrument consists of an electrical arc. When the instrument is switched on, this electrical arc produces some energy. So due to this, and heat energy is produced. So because of the heat energy, these two optical fibers get diffused each other. Because of heat energy produced, the optical fiber F1 and the optical fiber F2 will diffuse, and after diffusing, an index matching gel is applied over the diffusion portion, for better grip of these two optical fibers. So after that, it is covered by an polyethylene jacket or a plastic jacket for protection. So this is how an electrical arc or fusion method is used for connecting the optical fibers. So all these types are spiling is done for permanent joining of two optical fibers. Suppose if it is a temporary joint, we call it as connectors. Connectors are classified into two different types. Connectors are temporary joining of optical fibers. So it is again classified into two different types. One is butt joint connection and the other one is extended beam connection. So first let us see how butt joint is used to connect the optical fibers. Connectors. So spiling is for permanent join of optical fibers. So if the optical fiber is to be joined temporarily, then we go for connectors. Then we call it as connectors. So these connectors are classified into two different types: butt joining and expanded beam connectors. Expanded beam connectors. So now let us see how an optical fiber is coupled. Light from one optical fiber is coupled with the another optical fiber. So this butt joint is again classified into two different types, that is straight sleeve butt joint and tapered sleeve butt joint. So this is the arrangement of an butt joint. It consists of an alignment sleeve and guiding ring. So this is a material called as ferrule, a special type of material called as ferrule, which is composed of metals, glass or plastic. So the difference between a straight sleeve and the tapered sleeve is the sleeve. So in this case of a straight sleeve, the arrangement sleeve is straight, whereas in case of a tapered sleeve, the arrangement sleeve as well as the guiding ring is tapered. So that is the only difference. So inside the ferrule, at the mid of the ferrule, there is a small hole drill. So to insert the optical fiber, for example, this is fiber 1 and fiber 2. If these two fibers is to be joined, so through the hole the optical fibers, through the ferrule hole the optical fiber is inserted and the alignment is done by this alignment sleeve. So because of this alignment sleeve, the optical fiber 1 is made close to the optical fiber 2. Now with the help of the guiding ring, the two edges of the optical fiber are made to contact, so that the light from the optical fiber 1 is coupled with the optical fiber 2. This type of joining is called as butt joining. Expanded beam connectors. So let us see how two optical fibers, light from two optical fibers are connected or coupled by expanded beam connectors. So this expanded beam connectors consist of an optical fiber F1 and it consists of an collimating lens, and on the other side it consists of an focusing lens, and this is fiber 2. This is fiber 1. The light from the fiber 1 is to be coupled with the optical fiber F2. So let us see how the optical light from the optical fiber 1 is coupled with the optical fiber 2. So the distance between the optical fiber 1 and the collimating lens is the focal length of this collimating lens, is equal to the focal length of this collimating lens. That is, the distance between the optical fiber 1 and the collimating lens is equal to the focal length of this collimating lens. So once when the beam of light passes from the optical, is transmitted from the fiber 1, the beams are rendered parallel by means of a collimating lens, and after passing through the collimating lens, these beams are focused by the focusing lens and they are coupled to the optical fiber F2. So the light from the optical fiber F1 falls on the collimating lens. So this collimating lens makes the beam parallel and makes the beam to pass through the focusing lens. So after it passes through the focusing lens, the light beam is focused to the optical fiber F2. Now the light from the optical fiber F1 is coupled with the optical fiber F2. This is how an optical fiber is connected by using an expanded beam connectors.